All right, so I want to take a look at the idea of proving whether the square root of 2 is an irrational number. Recall, an irrational number is a number that cannot be expressed as the division of two integers. So that is essentially the definition of a rational number. So I want to prove that root 2 is irrational, i.e. it never ends. To prove that, one common technique is something called a proof by contradiction. So when you're doing a proof by contradiction, what you do is you assume the opposite, and you're hoping to find as you can probably guess, a contradiction here. So what we want to do is I'm going to assume the opposite. So if root 2 is not irrational, then I'm going to assume that root 2 is in fact a rational number. So therefore, and again, I'm looking for a contradiction to happen from this. Okay, so I'm going to assume that root 2 is rational. Therefore, root 2 must be an element in the rational number system. Well, the rational number system is all the a over b's such that a and b are in the set of integers. Okay, so therefore, if root 2 is rational, then it would be fair to say that root 2 can be expressed as the division of two integers. So I can find two integers such that root 2 can be expressed as a over b. Okay. Furthermore, and this is a really important assumption I want to make here, furthermore, I'm going to assume, and this is fair to assume, that a over b is in lowest terms. Right, so I'm going to assume that a over b is in fact in lowest terms. And that's a fair assumption to make here. You can assume a over b in lowest terms, because if it wasn't, then you could reduce it. Okay, so now going back to the root 2 equaling a over b, what I want to do first is I'm going to square both sides. So if you square both sides, you get 2 equals a squared over b squared. Well, if 2 equals a squared over b squared, then 2b squared is equal to a squared. If you take a look here, I have a squared equals 2b squared. It must be the case that a squared is an even number, right? Because we're expressing a squared as a multiple of 2. So a squared is even, definitely. Now, if a squared is even, then it must be the case that a is even. The reason for that, let's talk about why that has to be the case. If a was an odd number, if a wasn't even, either the number's even or odd, if a was an odd number, then a would equal 2k plus 1, again, for some integer k. Therefore, a squared is 2k plus 1 squared, which is 4k squared plus 4k plus 1. Therefore, a squared is 2. I can factor 2 out of the first two terms. And you'll notice I've expressed a squared here, if you look. I've expressed a squared as 2 times a number plus 1. So therefore, a squared is odd. So obviously we have an issue here. In fact, we have a contradiction. So you're kind of doing a little mini proof by contradiction here. If the situation here was we have a squared is even, and I'm concluding it has to be the case that a is even. If a was odd, then I've proven that a squared would also be odd, which was not what we had. So therefore, it must be the case that a is even. Okay, let's take this sort of mini argument. Let's just put it over here and continue with our proof here. So it's fair to assume here that a is an even number. Well, if a is an even number, then a equals 2k for some integer k. Therefore, 2b squared is going to equal, I can substitute in the 2k for a, and therefore 2b squared is going to equal 4k squared. Therefore, b squared is going to equal 2k squared. Therefore, b squared is even. Therefore, b is also even, using obviously the exact same argument we did above. So now I'm in a situation where a is even and b is even. But therefore, a over b is not in lowest terms, right? Because if you have a fraction such that the top is even, the bottom is even, we can at least divide by 2. So therefore, we have found our contradiction. We have found our contradiction. Therefore, root 2 is irrational. And that's the proof. The idea here, to remind you guys, is our initial assumption was that root 2 was rational. And every step that we did following down was correct based on our assumption. Based on the assumption that root 2 is rational, we concluded that therefore if it's rational, you can express it as an integer over integer. Obviously, you can write any fraction in lowest terms. And we went through and then concluded that therefore a over b is actually not in lowest terms. That was a contradiction to our assumption. So our original assumption was false, and root 2 is an irrational number.